basically getting together, learning, figuring out what we're going to do, and having really tight timelines for everything. And this is an extension of that as well. So every team is going to present 6 minutes. I'm Nate. I am the local lead for NYC. We have a few people who will come up and give some introductions, call out some people in the room. There's people from the American Museum of Natural History, Caveat Theater, Meta, bunch of people. A few of them will be called out in specific. There's local categories for judging, and by 3 o'clock today, those local awards are going to be given out. So really excited to be here. Thank you for all giving your time. We want to keep the judges rested, relaxed, and giving helpful feedback. So I'm going to turn it over to Steve from NYU. NYU SPS has been super supportive this year. We're at their space downtown. We worked here for the past 2 days up in the Midtown location. They've been such a gracious host, and I know there's a lot of NYU faculty here on the judging panel. So thank you guys for having us. And Steve, take it away.
Thanks, everybody. Thank you for being here. I'm going to keep it short, but I just want to say this has been a really exciting experience for all of us. It's been great to watch all of you work over the past 2 days and to see the ideas that are coming out. And I'm really excited to see your presentations today. So I just want to let you all know, we will be doing a special NYU award for those that apply to the NYU SPS portal. We have several judges here today who'll be looking at your work. You may recognize some of you who are students may recognize some of their names. I'm just going to do name, and then maybe if you all can just raise your hand so people can see who you are, that would be great. So joining us today are Joanna McNerlin, Stella Lupasor, thank you, Steve Wetzel, Samra Cosmi, Court Stroud, Ranjana Chowdhury, Raj Iyer, and Joseph Fang. So again, we're very excited for you all to be here today, and we're very excited to be seeing the work that you've done, and the faculty who've been sharing all these great skills with you. Now I get to see you put into practice. So thanks, everybody. And
I just want to welcome up Jaden Price. Jaden is our lead judge for New York City, and she developed a lot of the judging criteria. So go ahead and introduce yourself.
Hello, hi everyone. My name is Jaden Price. I am a digital strategy analyst at Adobe. So I work in their in-house consulting team, and I graduated a year ago, and hackathons were such a major part of my college experience. It really helped me gain the technical skills that I use now in my everyday life, and also some of the soft skills like project management, team collaboration, and creative thinking. So all of you here today, whether you win or you don't, you are winning the skills that you will use that will progress you into your career. So just want to give you a round of applause for being here. And also I'm joined here by my friends Roshni and Erin. Roshni works at Amazon, Erin works at Meta. They're both software engineers and excellent people to know. So feel free to talk to them afterwards or connect. But thank you all again for all your hard work and creativity.
Yesterday in particular, there was a lot of mentors running around. LinkedIn wasn't officially a sponsor, but there's a lot of people who work there who came in to give up their Saturday and who came today to help out the team, so call them out. There were some official collaborators. So Cloudflare has been working with us the past year to build these community events. We did one a quarter, a lot around AI, and there's a special award for use of Cloudflare. So I'll let Greg talk about it.
Hello everyone, yes, my name is Greg, and thank you, Nate. It's been a lot of fun sponsoring this event, and good luck to everyone who has been working so hard building out these very cool apps this weekend. It's been great to see snippets into what you've all been building as we've been wandering around trying to help mentor. So yeah, we're sponsoring the Best Use of Cloudflare Developer Platform prize. So with that, you would win 1 year of $5,000 of Cloudflare credits, 3 enterprise domains, and more interestingly, skip the line to our internships next year. We're hiring 1,111 interns in 2026. So yeah, good luck to you all. Thank you to Zach, Sid, Michelle, Annie for helping mentor this weekend. Yeah, good luck everyone competing. Great, thank you.
We just want to call out one more group that isn't here, MLH. Major League Hacking came in on Friday, gave a great presentation, and they're giving an award for best use of Google Gemini. So if you're a judge, look for Google Gemini API usage, something to look out for. There's also a special prize from the American Museum of Natural History, a project called Open Space. And I'm going to have Micah talk a little bit about that. Really cool award.
Right. Awesome. Hi, I'm Micah. As Nate said, I work on open space at the Museum of Natural History, which is the NASA open source, open data platform that runs our planetarium. And so we thought it would be cool as the prize that the best use of open space will get to bring their project to the planetarium, all load it in, and you get to see it on our giant screen and pilot it, and it should be really cool. But I'll just say, not only was I here as a judge, but also as a mentor. So it was just really great to be here the last 2 days and work with everyone. It was really fun and cool, and I'm excited to see all the projects.
And thank you all judges. I really appreciate your time being here. So we have a few groups that are ready to go in the back, and if not, we have some other groups. So DSIC is what I have as group number 1. Are you guys ready to go?
Yep.
All right, come on up. Tight 6 minutes.
Absolutely. Take 2, 3. I'll make 2 of those. Excellent. Minutes. Of course, yeah.
You can join the Zoom. Yeah.
Yeah.
Yeah, there we go.
Hello everyone. So here's Team DeepSeek, and we're working on the challenge called Meteor Madness. And we basically made an interactive web dashboard for this challenge, and we'll talk about it right now. So the tools we utilize first for the development, we use Maven to basically manage the dependencies of our project, and then Java for our primary backend development that we use for like 80 or 90% of our program. And also we incorporate some Python code because it just works easier for some packages and APIs that we. Oh, sorry. Okay. So that's there. And then for the NASA APIs and data, we use all these for different data for different subjects like asteroid, meteors, and near Earth objects. And then for the web development, we use JavaScript. That's the main front-end development tool that we use. And we also use some HTML5 and CSS for beautiful, more prettier designs. And then lastly, for the simulation, we use the Monte Carlo simulation for the data calculation. And then we also use all these 4 different physics laws and formulas for better and more precise predictions. And that's it for the tools. So for the dashboard itself, our platform provides a real-time access to the NASA APIs and delivering official data for asteroid fireballs and NEOs. And our platform supports automatic and manual fetch options to get latest data from NASA and ensuring the people get the latest updates. And on our platform, users can track, analyze, or monitor all these different subjects, and also most importantly, simulate the effect of potential asteroid impact with our presets, parameters, or users can input parameters by themselves. And next we'll have a demo video. Here we go. That is loading up our project. And here we can see like different data showing. And that is basically to see that we are fetching data real time. And here we have detailed description of what these data on the overview tab means. And then we goes to like the later tabs where we can alter different input by ourselves. And it will fetch the data from NASA like right away. And as you can see, you can change different time ranges and to set different just parameters showing. That's for the historical fireball events and for NGOs. And here we also used like different API keys, and there is a little problem with the NEO APIs from the NASA, so it only works with our primary. And as you can see, when we manually click back to the primary, it loaded. And here is the interactive map, and this is still under development. This only has the 2D version. We have a 3D that is still we're working on, and I'll show more slides on the next page. And here's a simulation we did, and it introduces our formulas and our results and takeaways here. And yeah, that's it for what we have right now. And so the last is the our under development simulation page that will go on the interactive map when we fully develop. And here you can set all the parameters and to get predicted impact for the certain meteors and asteroid. And yep, that's basically it for our project. Cool. Any questions?
Who do you see as the end user of this dashboard, and what would they be doing with this information?
It's just to basically get an idea of how like how much that impact would be, and to also reference to the historical data. As we see, you can filter and get what like similar events that happened before, and also to predict what might happen.
And who would be using that, sorry?
Just public use, Mr. Public.
You mentioned the simulation, so did you like ran some simulations with the like asteroid parameters and then changing the parameters to
Yep.
like make them crash? And so I guess my question would be like did you try some different ones and like, oh my god, too many are crashing or not enough, or like was there any parameters that seemed to make more of them crash than others, or?
Yeah, these are like parameters that we set in this program that can be altered, and of course you can like do a self input when you click this, but I don't have it running right now, so yeah. And it's all calculated based on this simulation with all these variables, and like the result is showing at the simulation page that just shows. Also,
So, thank you.
there's
That's not Fines by Branch.
Well, yeah,
That's it?
that's
Okay. And on deck is mission CTRL.
Thank you.
No.
Yeah, how do we connect our visuals?
So you gotta join the Zoom room and then present. You guys are in the back, join the Zoom, at least whoever's presenting. Bring on Slack.
Yeah.
Slack. Into the general chat. Yeah, that's it. And then you can share screen.
Yeah, we didn't know we're supposed to connect to the Zoom meeting before. That's our
You
apologies.
can choose.
Share your screen, your screen. Yeah, we want to share all the chicken. Oh, wait, no, we had it like, this is our screen that we want to keep on. Right there, that's us.
Okay.
But you can go to. Sorry, I'm. thinking about that. So I have a whole- Which one get it?
What team are you?
We are Fines, by Guntrust Big MLB. Thank you. We're going to. What do you like this?
Hi everyone, our team name. Hi everyone, our project is Finds Sharks from Space. And this project identifies and navigates data related to sharks from satellites. So basically it's mapping sharks activity hotspots from space using AI, Cloudflare, and NASA open data. Why did we build fins? Coastal safety and conservation depends on timely ocean activity data. And right now, traditional monitoring is expensive, it's localized and it's slow. So it's making all of these operations slower and not as effective as they could be. Satellite data is vast, but underutilizes in real-time decisions. So we asked ourselves, can AI help identify risky marine zones instantly? And of course it can, it's 2025.
2025, of course. So how can we use all of these beautiful AI platforms to make a project that workers in that'll be close to sharks in their area? How can they use this platform? So how does it work? We use NASA's data to or NASA data like the SST and the chlorophyll A. We also use Cloudflare's worker. We use Gemini to create JSON files for latitude, longitude, our confidence scores, and we also use R2 by Cloudflare. We also use the web PWA for Gemini from web to sorry, we'll fill in the blank. So we also have JSON in our stack, and we plan to make this available on iOS and Android, but right now it's just on web. So our architecture, like I said, we use PWA with Gemini REST. We use R2 cache. Wait, hold on. Yeah, that one. Sorry. Yes, we have open space for our 3D overlays. And next slide, please. Okay. Yeah. Yeah, so like I said about our confidence score, we're actually going to see our demo now and see what Gemini put out for us. So sorry. Yeah. So we are gonna spare you guys the load up, boot up details, and this is kind of what our platform looks like. So you can enter your region and also the amount of hotspots that you want. So like you saw, our thing is 200, and we are have a seed option. You can fast forward to the end of it where it was, and then also go to the Gemini board. I think it was video now. So yeah, it is still booting up the overlay for the open space API, but it does look a lot cooler and look a lot better. But as of right now, this is the current model state, and yes, and you go to the last slide, the closeout.
2 minutes.
Sure thing. So, we're all on the downswing. So if you wanted to keep up with our project, we have that available on our presentation link. We also have our GitHub repository that you can check out. And again, my name is Edmund Gunn Jr. I'm a master's student here at NYU at Tandon, finishing in December with a master's in computer engineering. And I'm with my partner.
I'm Yasmin. I'm a student at CAS in computer and data science.
Graduating.
I'm graduating in 2028, so I still have lots of time to go. Thank you.
Thank you.
We have no questions?
The graph that showed the sharks, like, that was based on a model that you made from those input, data sets?
Yes.
And so, I saw it showed Cape Cod, did you run it for other places, just for the one place, or was that a global and you just showed one subset, or like, I guess the different places about my question?
So, if we wanted to, well, we could do it for a second presentation. We could do New York, or we could do Miami or Fort Lauderdale, USA. But it just takes a little bit of time to boot up. As you saw, like, even after it booted up, it still took time for the overlays to do. So we would have had more, like visuals for you guys to see, but yeah, with time constraints, hackathon.
20
So,
seconds.
yeah, thank you. Any other question?
Hi, so do you guys have some sort of implementation for real-time data collection? What's the intended use case for this? Who are the users? And then lastly, as far as like Google Gemini usage, where was your major implementations for that and how did you use it in your developments?
So within 20 seconds, long story short, our project was mostly made with ChatGPT using my notes, and then we use Gemini to combine all the NASA data inputs from the shark in space problem. So that's where we got all of our data, is a shark in space problem. Those 6 data sets and the ones that Canada provided from theirs. And sorry, there's one more part of your question I didn't answer. What was that? Users. Oh, users. So of course our users are lifeguards, NGO educators, and city managers, people that would want sharks to not be around,
Those have been told with that. Join the Zoom if you haven't done so already. Right after that is NYU Atlas. Thank you guys.
Thank you.
Also for the judges, I know we're really tight on time to protect your time here. There is a Slack. If you want to join the Slack, let me know, or any volunteers can get you on the Slack. You can ask questions to teams. I just want to be efficient about the time up here.
Name, which name is it?
What's your team name? Mission Control.
Hello, thank you for having us for the NASA Space Apps 2025. We are Mission Control, and today we're going to be presenting our application Cosmic Sim for the Meteor Madness Challenge.
Hi, my name is Nicole. And as of now, NASA's NEO program is all about finding and tracking asteroids and comets that could come near Earth. But what if an asteroid struck Earth tomorrow? Right, with the near Earth asteroid like impactor 2025 poses like a rare but catastrophic risk. So here are the solution that we created.
So the name of our platform is called CosmoSim, as mentioned, and
The way that it works is that you upload files depending on like the type of data you're using. So we have 5 highlighted asteroid or meteor samples, and we also upload historical data of earthquakes. And as you can see, this is the first thing you see when you open it. And the purpose of this was to actually like make this a very like easy to use platform for any level of like users. So like if you're a student, expert, or even like a policymaker, you could use this. And the key features of this platform are that it models asteroid impacts with NASA NEO data. It is also able to simulate global atmospheric seismic and tsunami effects based off the uploaded data. And it demonstrates asteroid aftermath and approximate global effects.
So, hello everyone, my name is Arik. So for the user experience, the user can select the diameter, velocity, impact angle, and the water depth. We'll also have the possibility to select an asteroid that has passed near Earth. So it will include all those variables to the equation to have that. The user can select any part of the world, and the the meteor will be launched, and it will have different radius that will show. The green one will show the impact. The red one will show like the crater that will make. The blue one will show the tsunami radius that will also be impact, and the gray one will have the earthquakes that may happen, and lastly the orange one has the nearest city and how that city is going to be affected.
3 minutes.
All right, and then when it came to, I'm Brian. When it came to our data collection, I had to access the Near Earth Object Web Tools API. And then we also looked at the United States Geological Survey for the earthquake and tsunami data. When it came to data cleaning and preparation, it really helped to have AI help us speed up that process, that we can pass that information along to my teammates so we can run the simulation. And then when it came to actually building the tool, we used Cloudflare and the Workers AI, which will go more into detail in the next slide. And then with all these combined steps, we're able to run our simulation for our tool.
Hello everyone, my name is Matt, and just a quick overview of the technologies powering our program. So first, for our open source data and how we integrated it, we used NeoW with NASA's API, and we integrated that into Cloudflare, which would allow us to store and process our data in a more efficient manner. And then we also use the R2 storage specifically for security of the data management that it comes with, and also we use Cloudflare API workers to actually help us in our development, as well as other large language models.
Okay. Thank you.
Any questions?
So, were you able to run some real simulations, assumptions, and see the impacts? In terms of, so any one of the variables like seismic impact or whatever?
Yeah, so we actually just, the data that we upload is based off of the resources that were posted, like I think the earthquake data and everything was part of like the USGS, I believe, that was posted. So everything like regarding that historical data is like real and like actual events that happened. So we were able to upload that, and that's why when you saw the gray dots, I think it was on the next slide, it just records that historical data happened, and we're able to see everything like related to the area around the impact of that meteor. Any more?
What was your favorite part about working with your team during the hackathon experience?
15 seconds.
good part about doing this hackathon together is that we learn different things about each other, learning about our strengths and weaknesses and how they flow together, which is something that's super important and not only just a technical aspect of the hackathon, but overall our experience as a team.
Thank you. If you want to make that announcement. Yeah, judges, join the judges feedback channel if you have additional feedback. So we have NYU Atlas is up. If you guys want to present from the slides here, you can. Up to you.
I just connected.
Okay.
Thank you.
And then Homie Space Architects on Zoom after this.
It's not. Thanks.
I'll make it right.
No, you're good.
You guys.
Oh.
Have you ever have a coffee chat or even a day at Bryant Park and somehow suddenly caused stop by rain? So weather can do more than just moment. The weather forecast gives us data, but not the meanings. It says 30% of the rain, but when is it and where is it? And the users are usually guessing and the plans always fail after that. Actually, 67% of the users misinterpret the percent of chances of rain. And actually there's no context over what's normal in extreme weathers. So here comes is Atlas. Where we turn weather into decisions. Firstly, we have a smart recommendations constantly, which is an AI assistant that supports with planning with travel, logistics, health, and also safety decisions. We also have both location specific insights, specific into Bryant Parks, and we also have scalable insight views across different industries, such as education, research, and process management.
Great, so let's go ahead and hop right into that demo. We're gonna go ahead and visit that website, have it loading up. Of course, we're using Snoopy as a little mascot because you notice it has a little connection to NASA. And here we are. So this is Atlas. We're gonna go ahead and let's say that Jenny wants to go ahead and try to figure out if she could go check out the Griffith Observatory in LA. Now, this is something as an LA native that I really like and recommend if anyone travels to, but it is out in the open. You can kind of zoom in and see the place, but we want to try to figure out what's the weather going to be like, let's say around November 21st, how about that? So we're going to go ahead and try to see what the forecast is looking like. We go ahead, send that data. Now we're going to see it sending that request to our server. It's going to go ahead and run a REMA forecasting model on it, which is going to use all the historical data that NASA has on its service. As we can see, we get a direct results, and I would like to mention there's a little chatbot, kind of gives you an in-depth summary of the results we got and give you some recommendations. We'll dive into that a little bit deeper. So we can see the forecast results. We get the temperature. That seems pretty normal. LA is pretty hot normally, especially during this year. The temperature looks good, the wind speed. We also get a little bit of cloud top, and of course the weather probability. Now it says rain's about 28.6%. Across the decades of data, normally there's a chance of rain on this day. But as of recent years and what our model has predicted based on this, we were able to predict that is most likely not going to rain. And that's why we see that low percentage for 28%. Okay, how about, you know what, my friend has a birthday coming up and we're going to go to Bryant Park. I think their birthday is on March 7th. So we're going to go ahead and check out March 7th. And right here. Okay, so, you know, Bryant Park, out in the open, you know, do I need to bring an umbrella? What's going to happen, right? This is going to give you that direct result you need, kind of get in. And as we can see, it looks like it's going to be, yeah, temperature's a little bit nitty. We see the temperature kind of going around, the wind speed, the cloud top, also that rain as well. And then if we go to London, let's say Ricardo wants to go to London. I want to go Thanksgiving Day. Thanksgiving.
Mm-hmm.
Okay. Let's go ahead and go check out Thanksgiving, right? Because, you know, we want to make sure we're prepared right ahead of time. Getting that forecasting result as well. And take a little bit. There we go. And as we can see, if we zoom in, oh, it's snowing. It's because we were able to predict that there's a high % chance of snow and rain, also a bit of thunder, and we get this result directly here. Oh, in this case it's rain, yes. So then kind of see that. So yep, that was the demo. Let's go ahead and back right into the slides. Of course, it's the chatbot with the recommendations.
Okay, let's move on to the technology stack, and our front end and backend is separated. And so the backend is on my computer, and front end is on his computer. And after we get the request, we get the NASA data sets, and after data processing and model, we use Portly to visualize it and use the Google Gemini API to create a Snoopy chatbot, and use the Flask to build a server, and use the Cloudflare to make it public. And the front end can access, have a secure access to my backend. And after that, the response return to the front end according to the search element to visualize it.
1 minute. So Atlas helps people move through the world with clarity, confidence, and care. With Atlas's visual aid and with Snoopy's insights, you will never have an unexpected better day. Thank you. We were Team NYU Atlas.
Any questions?
45 seconds.
There's one question.
What challenges do you go through while building this?
This challenge is, will you rain on my parade?
I love that. What challenges did you go through while building this? Like any technology challenges?
Oh, definitely getting familiar with the map box. We also messed with Gemini, so fleshing out that chop out was quite nice. Of course, familiarizing ourselves with the technology, setting up all the API endpoints. So overall, there was a lot of technical difficulty with it, but then after we kind of like centralized our idea of what we want to produce, we were able to tie things together towards the end.
Thank you.
Cool.
Thanks.
If you have questions, we have to keep going. There's a judges channel on the Slack, and you can ask questions to the teams. Just note their names. This is a hybrid event, meaning we've had Zoom running like pretty much all day since Friday. No, that's not true. We cut it off. I don't left the building. But there are some people who have been participating and would like to be here. Some who couldn't make it on campus for various reasons. So the next group is a virtual group. I'm going to invite them to turn on their cameras and share their screen. And it is Homey Space Architects. Are you guys ready to go?
Hi, everyone.
Yes. Hello.
Hello there.
So still 6 minutes tight time.
Yep. I'm just share my screen. All right. Hello, everyone. We are the Homey Space Architects, and our mission is to make space exploration accessible through interactive education. This is our product, Skylab. Skylab, inspired by the first space station that was launched by United States. It's a space life simulation for students and astronauts. Again, the goal is to make space exploration accessible. If we make learning fun, it sticks better and you get further with it.
No, this is
Our mission, again, is to have fun. We not just let you have fun, but we also make sure our data is accurate. We use NASA's data and resources that we've been provided, as well as other online resources, to make sure our simulation is accurate and also fun and intuitive. So how do we immerse you in our environment? We have priorities and a maintenance mechanic, and these mechanics are essential to making the missions fun, but also challenging. You're going to have a crew, and you can manage them with a priority ranking that allows them to handle necessary tasks that you'll come across on the space station mission, as well as maintenance for keeping up with your gear and equipment and receiving data. Everything is essential to making your mission a success, as well as the crew members that you pick. Here we have a little demo of the mission selection screens. We have various different structures: hybrid, metallic, and inflatable. And the destinations are between Moon and Mars. Obviously, we know that the Moon missions Arterius are crucial to getting to Mars, something that we are very passionate about. We love to see people get to Mars. And here we just passed over, we have a crew selection screen also. The crew selection is very important because the crew members all have different specializations and roles. So when you pick a mission, you also have to pick a crew that best suits your mission. And these missions can have in-game times of 6 months to a few years. So you have to be very careful on staging your mission and picking the right people for it. And so what does the gameplay actually entail? We have two modes: play mode and design mode. Play mode is, of course, going to be the bread and butter, where you have all these missions to pick from, as well as the opportunity to customize and make your own goals and make your own missions. Because we know that if you're really going to have questions and you need to answer these questions, you need to have versatility and flexibility to make a mission that best suits your goals, as well as preset ones if you are just trying to make it through and learn a bit. If you're really just trying to learn and don't want the pressure, we have a design mode, which is just for creating an internal structure environment. And we have an intuitive system that helps the player learn and also build a structure that is both sound and going to help them succeed in their mission. That is it for this. We really hope to make education fun, and we really think we can help really change the game and bring a lot of people into this fascinating field of space exploration, which we feel like isn't getting enough attention. Thank you. We are Flo, Brian, and Eric, and please let us know if you have any questions. I think you're still sharing your screen.
I missed it, but could you tell me a little bit about your tech stack?
Excuse me, I couldn't hear you. Can you say that again?
Could you tell me a little bit more about your tech stack and what you utilized?
Oh yes. So pretty much this whole project is built in the Godot game engine. So everything's consolidated into this engine, and it's really nice and versatile for us to import a lot of data and also manage the assets and resources and import a lot of information, because the language GD script is a high level and easy to understand. So it's very easy to import data and information and allow us to point the parameters in the right direction. So relatively simple.
If I may add something,
Yes.
is that we also use 3D object resources from NASA, and all the document resources, learning about the Artemis missions and the Gateway spacecraft that are gonna basically determine how difficult and which parameters are gonna have each mission to be completed.
What kind of data are you using for like the crew selection?
Flo, do you want to answer that, or?
What kind of data are you using for crew selection?
For crew selection, we got also different roles and ranks from astronaut crews. So you have like a commander, a flight specialist, a surgeon. There are many roles and ranks, and you can assign each member crew to the gateway to stay in orbit or to land on the surface and go through exploration missions.
Cool. Thank you, guys.
Thank you.
Thank you so much.
Thank you for staying on time. Appreciate it. Uzma Kappa is up. Uzma Kappa. They're not here. Okay, we're gonna go to Persistent Voyagers. Ready to go?
I'll just, share my screen on the Zoom.
If anybody has any trouble with the Slack, just let me know and have somebody help you add it. But it's a good way if you have questions, because we're kind of keeping it tight. Invite your email. Or let us know if you have trouble joining.
Sorry, where's your Zoom? You can admit yourself up there. There.
Can everybody on Zoom mute, please?
You can also.
Yeah. I know.
What I had.
You know where I go?
It's the one that's actually like up right now.
Oh, it looks like they. Okay, go.
They find the.
Thank you. Take it away.
We can talk about things. Okay. You guys good? It's funny to do this.
Good afternoon, we are Team Persistent Voyagers, and we invite you to imagine this. What if the intelligence orbiting above us could be translated and integrated into real-world decision-making?
Could you use the microphone, please?
Of course.
There we go. Issues.
Can I start over? I'm gonna start over. We are Team Persistent Voyagers, and we invite you to imagine this. What if the intelligence orbiting above us could be translated and integrated into real-world decision-making? Every day, thousands of satellites in low Earth orbit generate terabytes of data, tracking solar activities, weather, radiation, and Earth's magnetic field. But this data sits fragmented, built just for scientists. Meanwhile, global systems like supply chain rely on these signals to mitigate operational risks. So we have space-grade data, but no business-grade translation. And so low Earth orbit comes in as the new data frontier. The current supply chain analytics market is worth over $10 billion, and the satellite data services almost 20, but they don't talk to each other. No one has built a system that unifies all these data sources and transforms orbital intelligence into actionable foresight insights. And this is the gap Solaris fills.
Sorry about that. Solaris is a predictive analytics platform that helps supply chain operators manage risks associated with low Earth orbit infrastructure. It combines real-time space and terrestrial data to support smarter routing and operational decisions by offering orbital business intelligence to our identified target audience. It essentially turns chaos into clarity. Under the hood, Solaris has 3 layers. It ingests raw data from space missions like Swarm and Ceres, interprets it using AI, ML, and Cloudflare, and informs the risk managers. When a flare threatens the satellite communications along a key shipment route, it identifies the at-risk shipments and alerts Ty, who is the risk manager, and suggests alternate routes based on real-time NASA heliophysics data, which helps Ty to proactively make decisions and keep deliveries on track.
There's a clear gap in our current competitive landscape. On the left-hand side, we have companies that offer scientific data and they lack operational excellence. On the right, we have no orbital context, but supply chain visibility. There are some companies that offer raw data, but unfortunately they lack insight, and that is the gap that we're trying to fill. We're converting NASA's LEO telemetry data into business-ready intelligence for our users to use immediately. This is our business model. It's quite simple. We drive awareness by ensuring that supply chain and risk managers are aware of our existence, and then we push them down to conversion by integrating ourselves deeply into their existing supply chain processes. In fact, we save $5,000 for every dollar spent on Solaris. Our mission is simple. We want to keep querying and dreaming big because we believe that the next realm of intelligence is not here on Earth, it's in the orbit. Thank you.
Any question, maybe?
you talk about operational insights. Give me an example of one of those insights that could be gleaned and then its practical application.
Absolutely. So an example of an insight is when you have an M7 class solar flare. A lot of these are words we might not understand. A solar flare is a change in the way that the solar winds move on the sun. Once that's detected, it impacts the stability of networks here on Earth. What that impacts our supply chain here on Earth, which means that fleets that travel over ocean, over land, over the air are all subject to some sort of disruption. And so we can identify those disruptions, offer alternative routes, and also possibly estimate our loss or profit counter. There's a calculation to that we've done on the back end as well.
Time. Yeah. Thank you. USG Ishimura. Are you here? USG Ishimura. Okay, so we will move on to NYU Nexus Nebula, and after that is NYC Smarties. So I have. Oh, they're in the Zoom? Yeah, make sure you're in the Zoom. So for those of you who are presenting, make sure you join the judges' feedback. I've been seeing a lot of people join and introduce to the teams. So if you guys have questions, the judges have questions and they don't get asked, you can ask it on Slack. You guys got all that MLH stickers, love it. Need some Cloudflare. Yeah.
All right, good afternoon, everyone. We are Team Nexus Nebula, and this is our weather companion. It predicts the weather, and to help us pack the right clothes and pick the perfect day. So what's the problem that we're trying to solve here? So travelers, especially new ones or the ones who are relocating to a new city, they don't really understand how the weather feels like in different regions. For example, 18-degree in a coastal area versus 18-degree in a mountain area feels really different, right? So they pack wrong outfit that leads to discomfort, or they waste travel days. And especially at times when they want to go out, there's a big problem to that as well. So what's our solution here? We are using NASA's Open Earth data to compute complex weather data into very human readable interpretation that gives a go out comfort zone outfit score, and it suggests you outfits and travel areas that you can go, and it focuses on making data usable for everyone.
So the 6 key variables that we used are temp, we got high and low temp, we got mean, and we got non-duration rain, and we had seasonal cycle that basically helps the model know that it's not a linear pattern but a cyclical pattern.
Yeah, the method we use is a convolutional long short-term memory. Basically, we chose this instead of like other statistical methods. Is like we want to predict longer into the future. For example, like weather forecasts are pretty accurate for the next day, but if you're talking about something like 10 days into the future, it's more of like a coin flip. But for our model, we're looking at 2 dimensions. So the first dimension is the convolutional dimension, which understands longitudinal, latitudinal locations. For example, in the red location, we understand that what parts will be hot, what parts will be cold, and for example, like when a storm comes, how it will interact. With that data, we layered it with also the LSTM, the long short-term memory, which understands over time, the time dependencies over time, how weather, heat, and everything will interact. And having these 2 layers, we can kind of find patterns, not understanding like predicting the future, but looking at over time, what are the ebbs and flows of weather and heat and how they interact over time.
Okay, so we have a short demo for you guys we would like to show. So let's just say I'm going to like New York City 3 minutes on tomorrow, and then we want to like check the weather there or like see what we can do there. So we can go
analyze the data, and it will give us recommendations of what should we do based on the time frame we have selected, depending on the activity we want to do. Do we want to go hiking? Do we want to sightseeing? Do we want to relax? It will give us recommendation based on that. So it will be like loading soon. It takes a little bit of time every time we do it. So here you have the current temperature, like on arrival. Then you have the rain percentage, weather score. Then we have the activities here, like what we can do on those days, and the weather would be suitable for those activities. And let's just say if you want to like ask a question, when should I go for a hike? So it will just give us the most optimal day to go for a hike. So let's just say like for a hike, Tuesday, October 7th looks like your best bet. It has the lowest chance of rain, like 20%, and it has a comfortable temperature around 17.7 degrees Celsius. So that's it. Thank you so much.
Thank you so much.
You can ask it.
Hi, so 2 questions here. So in your chatbot functionality, we were asking about the hiking. What AI model did you use for the chatbot?
Gemini?
We use Gemini.
Okay, so that was Gemini. And you mentioned that you utilized a convolutional LSTM. Could you tell me a little bit about, did you make your own model? Did you utilize an existing one? And where that kind of fit into the flow? Was that to determine the comfort score?
We have a developer for that.
Yeah.
You will answer that.
So I'm the technical guy, and I did some research before because I'm studying the machine learning stuff, and I got the insights about the LSTM, and that model can like perfectly fit in what we exactly doing about this prediction, and especially we're looking for the not only the time step but also the location stuff, and it perfectly like can converge together and make the by using the model make the results more accurate.
Yeah, no, I totally understand. And that sounds great. Was this an existing model that you already had, or
Yeah.
was it something that?
Yeah, it existed.
Okay.
Yeah, I did it before, and it's like did it
Really
multiple
well.
times. Yeah.
Excellent.
30 seconds.
What kind of data or process are you using to generate the what to wear recommendations?
That's Gemini again, but based on the region and the temperature, it changes. Yeah.
Cool. Last call for NYC Smarties. Do you want to unmute right now? All right.
Yes,
Uh,
hello. Hello, this is
You're here,
Daria, the
NYC
team lead.
Smarties? You're here,
Yes.
perfect. All right, another
Okay.
virtual team. Thank you, Daria, for showing up.
All right, I will share my screen right now. I also have my other team members present today, Nivea, Juanita, and Shimon. All right, so me presented. All right, so I hope everyone can see the slides. My name is Saria. I'm the team lead of the NYC Smarties team. And today we are presenting to you the Terra Trackers, which is an interactive and dynamic game that walks users through deforestation issues in the United States, specifically the Amazon basin that we chose as our case study. And it is aimed to educate people, specifically the users who are not very aware of the technical terms and the NICE data, to make them aware of these issues and call them to action. So a little introduction, we tried to address the challenge on emission celebration of Terra data by using the data from specifically the MODIS instrument that helped us derive data, for example, on the vegetation index that we used in our project. So a little bit in more detail of the concept. The users are walked through a little interactive game that has 3 clues focused on the vegetation index, specifically how the deforestation occurred through several years in Amazon basin, that it is aimed to demonstrate the before and after images of specific case of fire, in the forest and show the fire scar. And then it is aimed to demonstrate the results of the fire, how, for example, the smoke spread out across the region. We target the young generation of people, and specifically those who are interested in retro games, but we're also aiming at other people who might be interested in learning more about deforestation and the potential of utilizing NASA data. Now, regarding the resources that we used, we utilized NASA Earth Imagery API to fetch some data on the deforestation, specifically the vegetation index that is used in one of the clues in our game. However, we encounter certain issues with fetching the data. So to solve this issue, we also applied some demo data in our code, so the users can still see the accurate data according to the NASA website. We also use Google Gemini API to optimize the game narrative, and we use primary Cursor AI in GitHub to host our website and develop it. Something that we're looking for in improving on our website is to use the data from other instruments of Terra satellite, like for example, Aster and MISR, to provide more information to users and make the game more interactive. We also had an idea of using Gemini API to create an AI-powered assistant that will help users who are not really aware of the scientific terms to help them clarify this information and break this complex information so they can be more aware of the issue happening. Now we have a little demo video for you. Sorry about it. And this is all the information we have for you today. Thank you so much for having us for the NASA Space Apps Challenge. Feel free to connect with us on LinkedIn. Again, my name is Zarya. I had the pleasure to work on this project with Juanita, Nevaeh, and Shimon, and we're happy to answer your questions.
Questions?
Yeah, so this looks very cool. It looks like a very interesting game, but I was curious, what is the player trying to do? What's the goal? What's the player trying to do in this game?
So the goal of the game is to walk the users through a specific case of deforestation and forest fire, which we chose Amazon Basin. And the goal is to, through proof and evidence, to show the users that deforestation actually happens and make them more aware of the issue happening.
Other questions? All right, thank you guys. Appreciate your participation.
Thank you so much. We'll also be able to answer some questions in the
Next up,
Slack.
we have Galaxy Gazers. Are you in the back? Right, come on up. Oh. Interstellar Frontier is next.
Hi, we are Galaxy Gazers and Hi, we are Galaxy Gazers and we work on a project hunting for exoplanets with AI. So I'm Tanvi and my teammates Asmita and Srushti. We'll be walking you through our project.
Hello everyone. So this is our problem statement and our approach that we have used.
As we know, so many scientists goes through so many deaths which are even not planets. So you're putting your so much time in which is not even a planet and wasting our resources or something like that. So to be considered, we have this problem statement approach here. And so Kepler and TESS are the NASA data sets which have been used since long. Earlier it was Kepler and now it's TESS since 2018. So they found so many dips and shifts in the data, so it was not able to predict is it really a planet or not. So we trained our model using completely on Kepler, which is having the data sets which is used since long. And then we trained it completely on the test set, which is real time and using right now, which is 20% for the validation and 80% completely for the test. And also, so there is no leakage and physical awareness with using physics transformators. So we use two vectors as well to identify whether it's really a planet or not, to show it's a confirmed algo, a possible candidate or something like that. So these are the model accuracies also that we have shown and the features that we'll be considering further. We did use Google Gemini API as well for giving the explanation of that stuff that we are finding whether is it a real planet or not.
So the ML models that we built are XGBoost, like GPM, logistic regression, and Ensemble. So among these four models, we decided to proceed with light GPM as the final model because it gives a good balance between the stability, accuracy, and it does not even overfit. So after that, we predicted the star IDs, which are considered as the exoplanet. So among those star IDs, we verified them through the validation test dataset that we used. So now we proceed with the demo.
So we have exposed the API, the model on an fast API, and then we have built a Streamlit app to integrate that all into a front end. The researchers can ingest this data manually and try to predict the results. They can also set like what would be the thresholds for a certain amount of prediction. And we have also integrated Gemini API to explain whatever the results are being predicted. It'll just come up in a while. So these are just some values I've ingested to show that it can also predict a false positive based on the various. So this is the prompt that helps us with Gemini explanation through the API. We can also batch and we can also test in batches. So we can upload CSV files and large CSV files. We haven't included that in the demo because it would be taking a while to run, but we can download the results in CSV files as well. So these are all our app is also deployed on Render right now, live on Render and uploaded to GitHub. So these are the resources we use. Thank you.
Like 2 minutes.
You said you had, my question is about like the training. You said that you had trained it on the Kepler data. And I guess I wonder, like, after training it, did you ever try to like go run it again and see if it found the results, the original results from the data that you already knew to be true? If that makes sense. So like if you train it and then like maybe run the model against the original observation again to see does it actually find the one, the confirmed one, to validate the training.
Yeah, so we trained it on Kepler and we tested it on the test data set. So after predicting the star IDs, we also cross-checked it with the validation data set, the 20% that we had separated it from the test data set. So we cross-checked.
We did actually run it on the Kepler data set as well. The results were not as accurate, but they were pretty close. Yeah, we had some false positives there, but yes. Yeah.
Next, next up. We have, mission. Is that Interstellar Frontier? Yeah, mission control crew.
So that was Galaxy Gate.
Galaxy Case, okay, then we need Interstellar
Interstellar
Frontier,
Frontier.
yeah, thank you. Judge, it's only 60 more to go.
Fine.
Hello everyone. So before we start, I just want to get the story behind what we are doing. So every day we use different forecast app to see whether it's going to rain or it's going to shine or storm. But there's one forecast that we never see, and that's the air we breathe. Now I have one question. What if you could know that when it's safe to breathe, right? And we are doing that, not literally, but we are going to help you to see that what air you are breathing. So that's why we have made Lighthouse. Using NASA's Tempo satellite, we turn invisible data into visible action. Now, we during the app, we have tried tracking every minute data from NASA's Tempo, but in our application, we'll be giving an hourly based forecasting while using the NASA real-time air quality, wildfire smoke, and micro-level forecasting right where you stand. So we have three categories in it. Based on the objectives, we have created the categories. We wanted to make this app useful for everyone, be it children, adults, government officials, school administration, so that they can use it. And it is not just data, it is useful for making decisions. So that's why we have created a simple application that is useful for everyone.
So I'm going to be going over the features that the app has, starting with minute by minute air quality index forecast, which gives faster and more precise forecast rather than the hourly updates on the current apps. There's also age-based guidance. As my teammate Vishwa said, we can segregate as per elderly, children, and adults, and it will also give customized suggestions as per the air quality and the weather at that given point of time. So it adds a personal touch and is also a little more empathetic. Coming to the outfit planner, it's smart. So based on the weather and all the other factors, it will give you suggestions on if you should take your sun hat, if you should take a jacket, if you should take your umbrella, etc. And there's also an interactive 3D globe on the app, which is immersive, educational. You can interact with it, play with it, and go from locations to location, from global to local. So here's the demo. So right now we are looking at the New York's temperature, air quality. As I mentioned, there will be a role. So right now we have school administrator where he'll get to know what can be the best time for the students to go for the outdoor activity. And there are more categories just to see elder care, general public. So everyone can get the personalized messaging alert based on the categories we have selected. If somebody is immunocompromised or is a vulnerable adult, then you can click on the option right above and get customized results. So here is the forecast which we are getting. We also have the weather and air quality. In weather, you'll get the AI explanation on why the weather or the air forecast is based on if there is a wildfire or the population through the cars or any other pollution, sorry. So there will be temperature, what it feels like, humidity, speed, weather conditions, and UV index. We also have the AI air quality insights.
the recommendations, the NASA tempo that. Yeah, so the data sources we have used NASA tempo, which is like 182. We have used 3 ground sensors, which shows the ground stations, that is 90 and 90. And based on the combined, we get the AQI, which is the best accurate AQI we can get from these two data. The carbon dioxide, nitrogen, ozone. So and we also have a 3D globe, and based on that, this is the healthcare which we get through that. We also have the 3D globe, and if you click on any of the location, you can get the temperature and air quality for that. 1 minute. Yeah. So here is the trend analysis we have given. So based on these 7 days forecasting, we'll give the trend analysis for 30 days and 90 days, and it will give the accurate trend based on the machine learning we have used. So, we're open to questions.
Yeah.
Thank you.
One quick question? No. All right, thank you, guys. Judges, the teams are joining the Slack though, so feel free to ask questions there. That was Interstellar Frontier. So we had mission control crew and then astronaut at Astra. So right now, any mission control crew, are you here? Okay, ready? Come on.
Sorry, we did a we did ours as a doc. So we are the mission control crew, and we decided to do our NASA challenge as the stellar stories, space, and weather through the eyes of the Earthlings. So my name is Madison. I'm Danielle.
My name is Joaquin.
And I'm Ishan.
And so we're going to start off with how we use AI to build a story. So for our challenge, we decided to build a children's book with the character named Fiery. And Fiery is deciding to come to the Earth, and it's basically the idea of teaching children about NASA and space, and there's about CMEs and how basically everything that you learn with a science and a PhD in science can translate to ages 6 to 12, as well as education and entertainment. And so here is actually a little snippet of our book. It's called Fantastic Solar Adventure. So basically it's just through his journey as an individual, as well as a website to go along with the story that is still in progress, but we hope to have finished by the end of today. So we decided to divide the website and our story into 3 acts, which is the historical part of Fiery's story, as well as modern day and what the future holds for Fiery and Earth. And then for AI research and data integration, we strictly stuck with all of NASA's data. We went historical route with the Carrington event, as well as a couple live missions that they've done in the past, as well as historical weather forecasts.
We use a lot of AI to help us do our program. For example, we really employ the AI Gemini studio that helped us create a lot of images. We also put it all together, creating a story where people can connect through the book and to the website, because future generations, they need to be able to do both, read a book and find more resources online.
Which brings us to the results and impact of this digital story. So what we were able to achieve was complete a digital story with verified NASA science, leveraging the use of AI to help us break down a lot of scientific jargon that a lot of scientific PhDs understand, and else we're not scientific experts, and using AI helped us break down those terms, make it easy for us to understand, and help us make elementary school students understand this science. And that was part of our innovation and making educational content scalable with real-time NASA data.
So the key takeaways from this whole challenge is when you bring people from different aspects, like we're in PR, Ishan is in programming. We brought our minds together and we were able to achieve that. So he can go more into specifics of the coding language.
So for our tech stack, we use a white plus Next.js front end, and we also use Three.js to render 3D objects and animations. Along with that, we also use Gemini API and created a Python script which acted as an art director for our story, and it was used to create the sprites sequentially, maintaining that all the sprites are consistent in their image. Other than that, we also use NASA's Donkey API to create a small space dashboard at the end of our website, which helps you see modern recent events in space weather. And we also added Gemini to have a small quiz at the end, which changes questions as the difficulty increases. If you answer it right, you get difficult. If you answer it wrong, you get it easier. And in the end, we did our posting on Cloudflare, and we used it as we also used it as a CDN. That's all.
Thank you. Does anyone have any questions, comments, to say?
Thank you. You have a question.
Is this something that you would be interested in pursuing after the hackathon? And if so, what would you need? What would your next steps be?
I would say hire a graphic designer because the AI art director sadly does not work. If anyone is from Google is here, I mean no offense, but it doesn't.
Definitely it's something that we think would be in great use for a lot of students, because if we do look at the US literacy rates and just educational rates in general, we have great individuals here in STEM and tech, and we are the innovative leader in that. But the next generation that is still in school is sort of starting to struggle with that a little bit. And that would be a great educational benefit for them.
Cool, thank you guys. Thank you.
Astronauta ad Astra goes here. Great. And then Impact Crew is on deck.
Oh, somebody's logged in the Slack. Stop sharing if you're. That's really
Hello, we're the Astronauta Astra. I am Brian Zhang, and
I am Eduardo Santos. Nice to meet you all.
And we're presenting the project, our Gray Weather Protector.
little, we'll go over, like, introduce our weather app, we'll show like little pictures of demonstration, and we'll show our citation and resources we use. All right. Yeah, we're a team of 2 freshmen in IT system management at NYU SPS. And for our challenge, we did Boiler Rain on my parade for this year. And you briefly explain.
And briefly, we created this website with some help using Google AI Studio, which this was my first time using it, and it's surprisingly very easy to learn and use, especially when you give it, especially if you know how to give a good prompt to an AI. It actually gave us like very like defining results very quickly.
Yeah, and it also suggests what to wear depending on the type of event indicated, which is the AI system. Yeah. The first step you would do is you will enter in your location. So for this one, we chose New York City, and we chose December 10th of 2025. So around like 2 months ahead. Then you will let it load, and then you will read your prediction and suggestions. You have your summary in that middle text, and then you have your probabilities of having rain, the temperature in the day and temperature in the night, and then the wind and the how cloudy it will be on that day. And then additionally, you can ask your AI assistant for a suggestion, like, is this like a weather for a picnic? And it'll give you a response like that. We also have the voice. What do you call it?
We have a voiceover, an AI voiceover, just in case like someone is struggling to like try to type it out or read whatever the prompt says. It's also comes with the AI voiceover.
Yep. And here's our resources. We use the NASA space Earth data. And for building our websites, we used Google AI Studio. And Cloudflare, unfortunately, only hosted on Cloudflare, but we still have it on Google AI Studio if you would like to scan the QR code and test yourself. And we use Canva to make this presentation. And yeah, we would like to go for the Gemini and Cloudflare awards.
Questions?
It says that you use the space Earth data, but like, how did you, like, which maybe data sets, or how did you actually determine or guess if it was gonna rain?
Oh, right. Okay. The way that AI uses the Earth data is by, it takes that Earth data and it also uses like the previous year's worth of like data, I guess. And using that, it estimates like the date and the time and whether the season affects that weather. And or like, yeah, whether the season of the area affects that weather, and then it like gives you like an overall estimation of it should be like this because it's October or December or whatever the month and the date time is.
Any other questions?
What are pros and cons of having the image generator inside your output?
Oh, right. There aren't exactly many cons or pros, I'd say. The only real con I would say that this has is probably that it's not gonna be like the most perfect reenactment. Like here it says like it's crisp and clear, yet this AI image is just like kind of like small and not very detailed enough to.
It's meant to just visualize.
It's just to visualize like what the condition might be like. Like, for example, it would probably be better if it was like a snowy setting, then you would probably see like, oh, there's flurries of snow and less visibility. Or something similar like that.
Any other questions?
All right. Impact crew, you guys ready? So if anybody's watching on the Zoom, if anybody's here, we have a survey that just went out on the Slack. I'm gonna do a slide. Now's a good time to, talk about if you're participating, what did you like about it? What can we do better? It's really helpful for us to get that kind of feedback. And we'll post it up here shortly. You go to Impact Group, Unmask the Cosmos, which is a virtual group, is next.
Hello.
Hi, everyone. We
Great.
are, can we
Yeah.
start?
Yeah, go ahead.
Okay, perfect. Hi, everyone. We are Impact Crew, and the product that we're working on is Soul Map, which basically stands for solar mapping. So the idea over here is to tap into regions on Earth that receive maximum solar radiation, and then using that information to convert into a database for different organizations like the government, investors, solar installers. So to use what's there on our database, and basically we're going to be doing the due diligence for them. All they have to do is use our data and go and install if they think that's the right area for them. So yeah.
Yeah, so moving on, the database that we used from Earth data. So it's a clouds and Earth's radiant energy system EBAF data. So it has quite a few 251 variables. Out of those, we have selected 8 of them, and which were relevant to us. So basically surface, long wave, flux down, all sky conditions. We took the variable which covered like when there was clear sky, when there was cloudy sky, and when there was a clear day, cloud area fraction. So those are the variables that we thought were relevant for the amount of solar energy that could be harnessed, or it could affect that. So those are the features that we took from that data set. Moving on to the demonstration that we are able to produce the output.
Yeah, so we created a dashboard using Python libraries like Xarray, NumPy, Pandas. This is the first iteration that you can see. The next iteration is a 3D model that we created using, again, Plotly, which is a Python library. Here you can see that on the North Pole and the South Pole, the suitability score is very less, which means the solar radiation is going to be very less. And moving on to the function, the proper functioning of the dashboard. Here you can hover over the areas and you can see the suitability score along with the latitudes and the longitudes. The star area is our top site, which receives the maximum solar radiation. And the North Pole again is the lowest suitability. This is the climate of the optimal site over the year. And you can zoom in to see other areas to enhance and see the location at its maximum precision.
Yeah, so this is the basically the methodology that we used. Like we fetched the data from NASA's Earth data, then we used processing using Python, like we extracted the data set and the variables that are useful to us. Then using Gemini, we use Gemini to generate the this model, the Python group service model, and then we visualize using Google AI Studio as well. That demonstration is going to be next. My friend Vasu will show that demonstration.
So this is the first iteration through Google Gemini AI Studio. We can see the locations have been marked over here. We can hover. This is a much more smoother version through Google Gemini AI Studio. We can hover the location. Here it is the exactly pinpointing the location for the solar panels, and here you can see that it will give you exact locations, and directly in here's the GHI chart. It's global horizontal irradiation where it can presenting the monthly variance mean, and here is the final result. It is giving 0.9529 for the Chile location, and we have figured out this is the stop site, Sierra Gorda in Chile, and my friends will be continuing for the further presentation.
So the idea is to use the same thing for other sustainable energies like wind and thermal, but we've not worked on that yet. So that's us. Thank you very much.
If you had more time, what other data sets would you like to incorporate to get a more robust model for where to place solar?
I would like to answer that. So if we had more time. So what we did, as I said, like we only used 8 features from the entire, it had 251 features. So that the answers would have been much more precise, the numbers would have been much more crisper. So that's the thing. Only that data set is still unexplored for us yet. That's why.
Also, I think the data sets that we've used are up until 2015. We'd like relatively closer, recent ones, which we.
Yeah, also to mention, like the data set that we used, it covered data for 10 years from 2005 to 2015 to map. Yeah, the map was of that much.
I would
Yeah,
also
please.
suggest
Have you been
borders,
able
geopolitics, topography, the cost to actually install something there,
Yes.
something to think for.
Thank you. Yes, please.
Is there a way of looking at the data that you've looked at
Yep.
compared to like the data, the solar radiation in near Earth orbit?
I'm sorry, are you?
Near Earth orbit, the solar radiation, which would be more obviously,
Uh-huh.
and like
So so we have this chart. So basically this has something like we can clearly see like the radiations near the equator is higher, but for the what you are asking for, that variable isn't covered in our data set. We have also what we have top of the atmosphere and surface radiation levels. So that data set does have a variable which covers top of the atmosphere radiation levels as well. So that is.
So unmasking the cosmos, are you in the Zoom?
Yes, we're here.
Okay, great. We actually had a sort of a logistics thing about everybody who had to be on site here at NYU had to be 18 and older. I was very surprised and pleasantly surprised. I guess it's a group of middle schoolers with a mentor. Is that right?
Yes.
Yeah. Go ahead.
Okay, so wait. We are unmasking the cosmos, identifying the unknown with Shane Kelly, Matei Case, and Matthew Kelly.
Okay, so for this project, we decided on simpler machine learning algorithms. We attempted to implement a two-pointer algorithm. So we essentially sorted the list of planets that are available, and we automated the process of cleaning up and normalizing the data from the data sets that we collected, and we were streaming them to our algorithm, and our algorithm essentially sorts the planets, goes through goes through the items in the rows, and we essentially sort them, deleting the smallest or largest item depending on the goals for it, as well as to reduce the amount of memory we use for training our our AI, and we continue doing it until there's only one item left in each list.
Okay, so we chose to use a GUI user interface to allow users to interact with our system. So on the right, you can see an image of the GUI in its full glory. Just a note, on the actual website, you won't be able to see these little green text above them. This is just to show you what each of these like things do. So to find if your celestial body is an exoplanet, all you have to do is fill out these little input boxes, then click calculate. Yes, it is that simple. Here we have a little example. We're still finishing some code, but so here you have the interface, and then you input your data, click calculate, and then if based on the previously explained model, it will either say that it is an exoplanet and will give you this screen, or we'll say it's not an exoplanet. Also, we added a bulk uploading process to speed up identifying for large data sets. All you need to do is hit the upload CSV button at the bottom of the screen, select the file, and let the program work its magic until you see the complete screen. Then all you need to do is hit the download CSV button to receive a .csv list, which says each body's name and their exoplanet status. Yeah.
You guys ready for questions?
Yes.
All right.
What is like the science question you're trying to answer with this or asking?
Oh, sorry. So this is the hunting. This is a world away hunting for exoplanets with AI.
Do you want to clarify? Yeah.
Yeah. Is there anything specific about exoplanets you were trying to find out or trying to do here?
Well, so basically, actually, I think that's a question for Matei.
So essentially what we were trying to do was like the user gives us inputs about an exoplanet they found, and using the data we collected from training our model, we'd compare it to the values that we collected, and we'd use those values to see if the planet given to us by the user was an exoplanet or not.
Cool. Nice work, guys. How old are you?
I'm 13.
I'm 13.
Heck yeah.
Thank you.
Thank you so much. All right, next up we have data launchers. You guys in the back? All right, come on up.
Hello.
There you go, boys.
Hi. This is everyone. Hello. Hello. Please scan. Do you hear me? Please. Hi. Hello. Come here, please. Hi. Thank you. Thank you.
I think everything works well.
I already used it.
Do we need the microphone?
Ask that.
Okay, I mean, do you hear us well? Amazing. Okay, so I guess we're gonna start. Good afternoon, everyone. We're data launchers, and we were dealing with the challenge of commercializing low Earth orbit. This is our team, our respective responsibilities, and since we're short in time, we're gonna just move on to the story. So last summer in California, there was a man who posted a photo of the view of his house that said, "At least the sunset looks beautiful." Except it wasn't a sunset. It was a wildfire smoke that covered the sky, thick enough that covered the sky with orange colors and blocked the sun for 3 whole days. Can you imagine living with without the sun for 3 whole days? I personally can't. So wildfire in one area and billions erased from the balance sheet. And that's how we're going to move up to the numbers. So in 2024, the United States lost over $180 billion to wildfires, heat waves, and floods. And we don't like those colors.
Yeah.
They're very intimidating. And imagine being an investor holding $500 million in property, or a farmer praying for rain, or being a satellite operator or an alien client praying not to hit human space trash. So as our dear colleagues and future clients, you might be asking one question: where on Earth will wealth survive the climate's future? So climate change is now a financial threat too. And insurers are pulling out of the high-risk states like California or Florida. Developers are mispricing the land, and farmers can't predict the rainfall anymore. Meanwhile, NASA, USGS, and other agencies are collecting terabytes of satellite data every single day. And you know what the tragedy is? It just sits unused, like a golden library without its key, collecting dust. So you know what the key is? Next to us is a key. So Houston, we actually solved the problem.
Think ChatGPT meets NASA, but instead of writing your poetry, it helps protect your $500 million investment from flooding, burning, or floating away. But what does this look like in action? Let's go live. So here in our demo, we're looking at the next to us prototype dashboard. So first, let's click on San Jose. What does it show us? Within seconds, our model is able to interpret the data to show us the flood probability. the air quality trends, and the wildfire exposure. Now imagine the same level of forecast accuracy and granularity for any property anywhere. That's the power of predictive climate foresight. So let's play out 3 real-world conversations that we've actually encountered. To begin.
Hi, I'm Farmer Joe. How can your app help me? Hi, I'm Sophia, a real estate developer. What can your app help me?
Hi, I'm Zor, developer. I don't want to buy human satellites. How can you help me?
Alrighty, to begin. Joe, NASA's SMAP and GPM satellites tracks soil moisture and rainfall from space. Next to us turns that into a 5-year probability forecast to forecast the probability of rainfall for your specific farm coordinates. And Sophia, if we're looking at your site in San Jose, we're seeing increased wildfire probability in about 10 years. You're probably going to want to move that. And Zor, our precious alien client. Next to us detects an invisible debris cloud, which your launchpad crosses. So I recommend that you move that. Now, how would a regular citizen use this? Let's go to our next demo. So here we are going to be asking our next to us model, is it safe to buy a house in San Jose in 2040? And next to us, we'll reply with the following data of flood risk, heat index, and air quality. It even adds a note that this property has a 40% lower long-term climate risk than the region average. All of this isn't just data. This is your peace of mind.
So next to us connects Earth and orbit. When we start with California or Florida, doesn't matter. Then we expand to US and then the whole world. So every home buyer, every insurer, every alien client that disgusts humans so much, they're gonna ask one question one day. What does next to us have to say? So we're not asking you to invest into another app. We're asking you to invest into resilience, clarity, and hopefully into the Earth that can still breathe tomorrow. Because the next frontier of intelligence isn't just up there in space, it's right here. Next to us.
Any questions?
Can you talk about monetization? So who would pay for this? Is it something that's integrated into an existing app? You have to be acquired?
I can answer that better. So we're basically a B2B company right now. So there are 2 stages that we're going to be expanding in that we're thinking of. So we're thinking B2B and B2 government, and then the second stage would be B2C. So we're also, like Marua said, we're launching an app, but it would be available on phones as well. So the consumers can directly check. So we have like different tier models for it, like different monetization models. On the QR code, you can see all the plans.
Well, I'm on it. Thank you.
Thank you.
Oh, and we also have a GitHub that's the actual code for the actual app. This is just a prototype.
Yeah.
Thanks so much.
Time.
It's okay. That's your job. You're doing it. Hackers here? Yep, come on up.
Thank you so much, guys.
Thank you.
Yeah.
Hi, guys. That's my cat. One second, guys. Okay. So thanks so much for being here today. We are the GeoHackers team, and we are doing the data pathways to help
healthy cities and human settlements. So for that, we chose Sao Paulo. That's a city in Brazil that has been facing a lot of flood, and that's been affecting like people that were having to like put up replace their houses and nice. And usually affects people of low income, and that's the issue that we wanted to work on and understand how data can help planners prevent this. So for that, we created SafeGround dashboard that integrates NASA precipitation, soil moisture data with city housing permits and sensor equity data to try to understand how to prevent like people living in those places. So with that, we created a model that runs geospatial overlay analysis combining flood, housing, and equity layers. So users can test feature scenarios like, for example, seeing like if 15 new housing units are built in some specific area, how many residents will face risk in like 2030, something like that. So the dashboard produces AI-assisted policy summaries ready for city planners and resilience agencies. So then I'm gonna have a demo of what we have. Like that's.
So basically over here we have the dashboard, and so here you can see that the main indicators will be like 7 high risk flood zones. It's just demo data. 7 housing developments, 12 vulnerable communities affecting over like 17,000 residents. And so quick high risk filters that would be like high risk permits, SPIs, which let loan planners instantly find where new projects intersect with danger zones. So we can scroll down to the map view. So each color represents what we can see here. So that will be like flood risk zones, housing developments, vulnerable communities. So coming on to the scenario testing tab, yeah, the top. So this is where SafeGround becomes a decision support tool. Planners can project new housing developments, for example, like, you know, for entering a 2020 East Zone expansion scenario. And so we run, yeah, and we run like scenario analysis here. Oh, 1 second. So just that. Okay. So yeah, sorry. Over so like just 2,000 units, for example, and that would be here. Analyzing, and so it's basically AI powered assisted geospatial analysis tool which can calculate risk weighted analysis. So coming on to the slides, yeah, just changed. So the impact would be like SafeGround moves beyond mapping, it just drives action, guides where not to build houses, new houses, helps prioritize resilience funding, empowers communities to advocate for equitable infrastructure investments. And the future envision would be like, you know, adding real-time rainfall alerts, enable AI assistant for automated policy briefs for urban planners, integrate citizen reports and community feedback. And also like, you know, it should expand to other cities in Brazil and other global areas. And just ending with like SafeGround helps cities build housing that's not only affordable, but safe, equitable in the face of climate change. And these are the like platforms we used. Thank you so much.
Any questions? Yeah.
Yes, less of a question and more of a comment to say like this is like something that I see like cities and governments needing and using right now. So really awesome.
Thank you.
Yep. Okay, thank you guys. Incognito mode, you guys ready to go?
We're ready.
Ready?
Yes, 1 second, let me share my screen. Can you see my screen?
Yep, now we can.
Perfect, okay. So sorry, hold on. Okay, my name is Anna, and we are incognito mode, and we were doing the Embiggen Your Eyes challenge. So our mission was to create a tool for users to be able to zoom into distinct features of different space objects and explore their development through the years. And we got inspired by the way that Google Earth and Google Street View is used. So this project splits huge NASA images into smaller tiles, and when users zoom into a feature, they can get a detailed view. So I'll hand it off to Kelly.
Yeah, so how many of you have gone onto Google Earth just to browse when you're bored and you just want to explore different things that you want to see on the map? So for our project, we were kind of inspired by that because when you zoom out of a Google map and you enter globe view, you're actually able to view the 3D assets that NASA provides. And you are able to see different landmarks that they have. But the issue is that you click on it and it doesn't tell you anything. So what we did was we took that same like satellite imagery from NASA space tracks, and then we configured a map so that it was able to overlay the coordinates of the map with coordinates of known features. So this would be like craters on the moon, mountains on Mars. And when you click on it, we are able to load a lot of information so that you interactively learn about the map as you would with Google Earth. And then we added some more niche features so that you can have a more well-rounded learning experience. So if you were just browsing and having fun, or if this was a museum or classroom setting, basically you would be able to select features on the map, and then you could also do a comparison and see how different features may have formed over millions of years ago, because the solar system, or at least the items that we chose, are from the solar system, which formed about 4.5 billion years ago. So our timelines start at 4.5 billion years until present day. And it takes information from all sorts of NASA mission reports, US geological surveys about these different features. And it creates a dynamic timeline that shows when it formed, if there was like a major eruption, until current day.
Yeah,
Okay,
and
so sorry.
Yeah, the code was deployed on using Netlify to host the website and was routed to on a custom domain using AWS Route 53, which you can access on space.alausan.com, which is spelled space.alausan.com.
Okay, so I'm gonna go ahead and do a demo. Just, can you still see my screen? Yes, okay, perfect. So when you go to the website, you can select a celestial body. So for this example, I'll do Mars. And then you can kind of zoom around. If you zoom in, the picture becomes clearer because of the way that we use the technology of like different tiles. So for example, if I wanted to compare, let's say, this huge crater here to something much smaller, I would do a bounding box. And when I do a bounding box, the little stars represent features that are available from the data that we used. So let's say I want to compare this. I'll click compare features. I'll click on this one. So this is Madeline. And then I'll pick a different one. I'll pick Airy. Oh, whoops. Available. We'll do uh-oh.
We
Sorry,
can
let
do
me just
the mountain example.
Yeah, let me
So,
just
so you're able to, if you already know the name of the feature, you're able to search it up. So in the search bar, if you search up Olympus Mons, which is the tallest mountain in the solar system, you click on it.
Olympus Mons.
Yeah, so when you click on it, it'll give you all the information about where it is, what it's named after, and then some other supplementary satellite information about it. And then with the comparison tool, you can compare it to, let's say, another mountain. I think if you go to your right a little bit, it kind of looks like a pimple, I'm not gonna lie. If you click on it on the right. Yeah, like one of those
That's it.
mountains.
Thank you for your time.
All right, thank you.
Thank you.
Can be directed to Slack. So Pixel Pals, are you on the Zoom? Pixel Pals going once, twice. Pixel Pals. How about Phoenix Alpha? Phoenix Alpha.
Yes, we are available.
Here?
Phoenix Alpha. Phoenix Alpha.
Phoenix Alpha, you're good to go then.
Okay, is my voice is clear?
Yeah.
Can I share my screen? Okay, is screen is visible? Is it visible?
Yes.
Okay, we are a team of 2 members. Hadid Ahmed is our leader. So our main challenge is a world away hunting for exoplanets with AI. Out of 5,600 confirmed exoplanets, but their data remains scattered. They are confirmed exoplanets. Scientists struggles to visualize and compare planetary characteristics effectively. Current tools lack interactive features for exploring, and key stats are 99% of pupils have never explored exoplanet data. It's alarming. So our solution is here, ExoLoom, NASA Exoplanet Detection, an intelligent web platform powered by ML that uses the 3 datasets. The resource of datasets is the resource sections available on the NASA website. The datasets are Kepler, TESS, and K2. The core features of our solution are mission overview. First of all, we gave the dashboard where we give the overview of all 3 datasets. Then there is a prediction section where we gave the instant prediction using the advanced ML models, LGBM classifier, XGB classifier, and CAT boost. Next, there is a portion of batch prediction where you can instantly get the give the CSV file to our web platform, and then in return you get the predicted CSV file. Next, our performance analytics, the model accuracy and validation results of all 3 datasets simultaneously available on the web platform. You can compare the results also. Technology and architecture. Data source, of course, from NASA exoplanet data, Kepler, TESS, and K2. Front end and hosting is in Streamlit Cloud. Visualizations, Plotly for 3D planetary results visualization. Our features are data pre-processing, then machine learning models for the evaluation and model training, then predictions and performance visualization on the base of 3 datasets. Then batch prediction option also available. Next is our main focus and our users. For students, students can easily get hands-on and explore the NASA astronomy education for engaging and memorable experience. Researchers can also use to compare the accuracy and models of the by using different data sets at the same time on the same platform. They don't need to get hours to explore the different data. Now they can explore it in minutes. And we successfully visualized 271 features and 16,132 samples of exoplanets. This reduced the data exploration time, of course, from hours to minutes. Our real-world applications, educational institutions can use this platform, and researchers can also use. It will help. Our future vision, expanding Exolume's horizons. We are looking forward to embedded both Kepler light curve data and the tabular data, and we will implement the deep learning architecture to improve accuracy. Next, real-time alert system. Whenever new exoplanet will discover, then we will get a notification. And available API for the researchers and educational institutions. And we are also hoping for a mobile application for this, so everyone can get access to this exoplanet datasets and exoplanets information. Now I would like to show our web platform. Here is our web platform. Our solution name is Exolume NASA Exoplanet Detection.
It's still showing the PowerPoint.
Okay. Is it clear?
No, PowerPoint.
PowerPoint.
Yeah, you need to unshare and share the full screen.
Is it visible?
No.
I will try again.
There you go.
1 sec. And now, is it visible?
Yes.
Here is our web platform. Exolume NASA Exoplanet. Here are the 4 sections: mission overview, first Kepler mission, test missions, and K2 model. Here are Kepler details, test details, and K2 details. Next is our prediction section. We will select the dataset from here, test, and here we give the little bit detail, and then user will give the input using these columns and predict exoplanet here. A very attractive and simple UI. And here is our visualizations of the results and prediction details. And here is our.
That's it. That's it, guys. Post on the Slack any links you want to share. Thank you.
Thank you. Thank you.
Okay, Space Biology 101. Are you here? Space Biology? People scrambling. Can you believe we only have 40 more to go? No, we have a few. There's a few people who. 1, 2, 3, 4, 5.
I'm gonna share around the Zoom.
Wait, no, we're just waiting for the slides to come up.
Oh, you can pull it up. Just use the. Should just be in that folder right there.
There you go.
Hi everyone. We're Space Biology 101, and we built a smart search engine for scientific publications and knowledge graphs. So the problem at hand is, how do we make the lives of researchers and publishers easier? It's by reducing the information overload, which a lot of researchers are facing right now, and they're also limited with the keyword search. So our goal was to make the lives easier by building a tool, an intuitive tool that helps them ask questions and get pinpoint answers to what they're looking for. And so our solution consists of a RAG-powered application. We built a web application that uses retrieval augmented generation and to provide a conversational interface for the researchers, so they can ask questions to it, and it will cite the sources and also give its answer to the question from based on the sources. So our system architecture consists of a two-stage process. The first one is to index the initial data that's coming in. We obtain the data from NASA's official website, or the page for the competition. We were given 608 publications. We web scraped them from the publications website, and we chunked those each and every paper in chunks of 1,000 characters with some overlap between them, and we also obtained embeddings through bypassing the chunks, and we also stored them in a vector database for easier indexing. And we pass a user's query, and we obtain five embeddings that are closest to the user's query, which also gives a context for the context which is closest to the user's query. And what we do then is the generation part, which we pass the context along with the user's query to an LLM. In this case, we used Google's Schema, and we get a response for it through the response is the answer for the question that the user asked.
So apart from our RAG-based application, we also developed a visual-based representation where all the papers are grouped together such that similar papers come into similar brackets. So as we can see here, we have divided the 608 papers into 7 different clusters, which are shown in different colors. So if a researcher wants to know any other similar papers, he could just go use this tool to find out other similar papers as well. So in our future work, we also plan to use base 44 to get a more 3D structure out of it. As of due to time constraints, we are just able to develop the 2D structure. So we will use base 44 to generate a 3D graph as well for that. So thank you guys. I'm Rohan. I'm a master's student in EC at Rutgers University.
And I'm Martin. I'm a master's student in physics.
I mean, are you looking to get access to more papers? It looks like this is something ready to go. I could be using this tomorrow as a researcher. What am I missing? If I gave you $1 million to make this a company, like what you have left to do, or why would you say, maybe not, or?
So the biggest problem we faced was with this scraping of data. It wasn't exactly structured. So if we do have a lot of data, that would make it easier. It would give it more. We can give more context to the model itself when we're generating the answers. So that would be very helpful. Yeah. More data, obviously. But
I have a question. How would you protect yourself against shadow libraries? How would you protect yourself against shadow libraries? Shadow libraries, which is research papers tend to get passed around a lot, and so how would you protect yourself against the theft of the research papers?
Research papers. So, if I'm understanding correctly, it's, so the research paper, the source of the research papers are not, what's that? We would, since we're web scraping, we can make sure the source for the websites would be legitimate. Like the one that was provided by NASA was a legitimate website. It was just a list of publications that we should consider. Maybe we can consider only the publications in our website because that's not okay. We can limit our sources.
So you know you were not stealing.
Yeah, we were not stealing. Yeah, since we already had a list of, and it was open source, so we could easily.
Next up is space and innovators. Space innovators. You're here? Down.
Yeah, sure.
There were two Space Innovators folder, maybe you were in the second one. First one?
Yeah.
I'm literally scared.
It's like that. Back in the motion goals, you know, the secret money. You know, it's like a secret, it's a secret. I did hear you about it. You feel no.
Okay. So one rock moving faster than a bullet could end life as we know it. And unless we give it the tiniest push. And today, that's exactly what our team is going to be exploring. How early and small actions can prevent Earth from a massive cosmic threat. So, hi everyone, we are Space Innovators, and today we will be exploring meteor impact through our interactive simulation. So what is this? By using the real NASA and USGSG data, we tried to transform complex scientific concepts into a simple visualization, ensuring that anyone can understand and explore the potential effects of asteroid impacts on our planet Earth. So let's talk about the exact problems that we're trying to solve here. The first one is catastrophic consequences of meteor impact. So here you can see the consequences that we can face if we don't avoid it on time. Widespread destructions, loss of lives, and severe ecological damage. The second problem that we will be trying to solve here today is actually a lack of interactive platforms. So today, there's not actually a dedicated platform that allows users to interactively test the what-if scenarios regarding asteroid impacts. And I feel like that's exactly what is limiting us today from overcoming those cosmic threats. The next up is the solution that we will be providing today.
So, nudging asteroids should be the first line of defense. So what happened to dinosaurs should not happen to humanity. So for that, the main threat is asteroids can hit Earth. Yes, it's very much possible. So the solution is we gently push them, and even a little small push like 0.001 kilometer per second can deflect it from its orbit, and it will be enough for it to miss Earth. So you might have all heard about the NASA's DART mission. So it was one of them, and this will prevent the huge impact. And let's say, what if we miss the impact? We should be prepared for it as well. So we map the impact and we prepare for worst as well. So the problem here is, if asteroid hits, we should identify what can be the possible geographical elements which are affected the most. So oceans are one of them. So we are simulating that impact, and we imagine asteroid hitting the ocean using NASA's fireball data, and you can see the screenshot over here. It is reported by US government sensors, and we should also identify the risk using the USGS elevation data to show exactly like which towns and cities are in the most dangerous zones. And the key message here will be we combine space data with Earth geography, and it will help us to prepare for the potential asteroid threats. And let's now go to the demo, and my friend will be presenting.
Okay, so now let's look at our web app. So this is what we built, and basically you can model the impact of any meteoroid by inputting these 4 parameters. So there's this asteroid diameter, the speed, the impact angle, and the material. So after selecting these parameters, you go on to select any location. So for now, let's just
Let's select New York.
Right, this is not, the scroll wheel is not. This is opposite. Okay, let's just select any random location. And once you launch the meteoroid, you can see I'm sorry, the scroll wheel is not working properly. Okay, so you can see the crater diameter. So this is the crater, this is how far the debris would be going, and that is how far the seismic waves would be going. And if you scroll down right here, you can see some more data about the impact location, the total energy that will be released, and there's some more tabs that show the some information regarding the crater, that's crater diameter, crater depth. Then this location about the fireball. Yeah, this location about the shockwave that will be created. This the wind information, like how far the shockwave would be going, and how many people that might affect. So actually for a lot of this data, we have used the World Pop API to get the population density of any region, and using that we can let's say if we drop the asteroid over the ocean, then you can see that it won't be.
Thank you, guys.
Yeah.
Okay, Skywalker is 77, and then merge conflicts. Skywalkers.
Okay, we'll also be posting the link so you can try it out yourself.
And the data are actual NASA data, sure doesn't.
Skywalkers 77. They're coming. Okay. Great.
See what slides on.
Right.
Please share your screen when you're on the Zoom, so anyone watching remotely can see your slides.
Recording in progress.
We are sharing. एक second.
Recording in progress.
Share, not share. Yeah.
Oh, yeah, maybe co-host if you wanted to share.
No, like we have multiple desktops and we want.
Inside your.
Yeah.
Turn the mic off when you do it.
So like basically we have three desktops. Yeah. We can share my
No, is it to
Does your laptop have the permissions assigned to?
That's what I was saying. Can you make her a host?
Well, click on the share button at the bottom and see if it works.
Share laptop, yeah.
Yeah. I'm saying you can share for there.
But the answer is this desktop will.
Show the toolbar at the bottom and then click on the share icon that's gonna be
They
there.
are doing, it's not, but it's not actually, for some reason Zoom is not reading whatever the tool is that we use.
Can you guys just show the slides and talk through it?
Yeah, just talk through it. then.
Yeah, just talk through it.
So much for that.
It's done,
Yeah.
it's done, yeah,
Yeah.
it's. Join. Don't have them. Share. Okay, yeah.
You do share everything. This is desktop only. Even plans because we are on this group. Actually, you can.
Yeah, it's coming.
Yay.
Thank you.
Sorry, I should have kept my mouth shut.
Yeah.
Yeah. So my name is Krish. This is my team. And the project we have chosen is Space Biology Knowledge Engine. And there is a particular problem that we are trying to solve. And that is that currently in NASA, they have almost more than thousands of publications published. But when the scientists want to find some particular information, it takes time for them to, find the right publication they should refer to. Like if they want a knowledge on particular topic, it becomes difficult for them to, know like which research paper to go through. And sometimes they have to go through the whole research paper. So we have created a solution for this. And yeah, this is the problem right now. Like they have thousands of publications. For this, we took a data set of 600 publication. And yeah, so to solve this, we created a product called Astro. And more to my teammate about Astro.
Hey guys, I'm Yatharth. So this is our product Astro Rack. It's a retrieval augmented LLM which is trained specifically on the NASA biology data publications data set. So what it does is, as compared to traditional LLMs, right? If let's say there are two publications from competing agencies, they might have different standards. So if you go to a general LLM, it won't know which to grab info from. You can't constrain it. So when you train it on a specific data set, you can change the parameters. You can ask the model to be constrained to a specific data set. So that's the plus point of having the RAG versus a traditional LLM. Okay, let me go in. So the thing is, let's say you have thousands of data sets. How do you, let's say you have thousands of publications. How do you know where to search from? So how do you know where to search from? Typically this till now, I mean, for the last 70 years, it has come through experience. You join an organization, you work there for 5 to 10 years, you come to know where to look at. But with the onset of LLMs, this has been resolved. It has been, I think, instantly you can look up where the LLM will point you out. Right now, the traditional LLMs that we have, let's say ChatGPT, let's say Gemini, let's say Perplexity, they don't show you the sources where they have picked it from. So that's what RAG enables you to do. It destructures the thinking it has. The opaqueness of thinking is removed. It tells you the sources it picks, and if you want to go more in detail, if you want to verify the fact, you don't trust the LLM, you can simply go to the fact and verify it, because it will cite the sources that it takes, and that's how you know that the facts that have been taken are from your own dataset and not from the internet. Now we'll move on to the demo of the product.
Yes, so coming to the demonstration of the product, we have created a recording for it. And you can see Astro is our UI here. You have the upload button, you have the speaker button, you have everything. You can upload files, you can upload images. And right now, suppose, yeah, okay, fine, it's going too fast. So the first thing that it searched was wait, just a moment. What's the average age of the mice when do we launch mice for any experimentation? Like any research lab, you would want to experiment on something or the other, let's say a mice. So we had the data set for that, and we put a prompt. We had already, and yes, to tell for first thing, this is all having the open space data set from NASA. So it will be grounded to what relevant data is being uploaded here, and it has been trained on NASA data only right now. So it shows you carry the research on mice, and it will show you the optimal age of mice. When do you have to launch that mice? Maybe when it is fully mature at 4 to 5 months, you can start. Even like it just gives you the actual correct on point justification, and also it cites from which document did it take. So let's go to the second prompt. So the second prompt, like as a biology scientist or a bioengineering person, maybe you would want to know what happens when in low gravity, when you go to space, what happens to our hippocampus pathway of the brain. So, I mean, does it deactivate or not? So we put the particular prompt that discussed the deactivation of hippo pathway, and it did provide that in microgravity what happens, and that is also cited by few sources. You can see here that it has cited from all the sources it has picked up from the NASA open source data. And this is how we have like created a lot of prompts, and we have generated. But then to know what is actually the ground truth of the data, so the final I just said, just to be so I just said, how you doing? Any chat, you go to ChatGPT, you go to Gemini, you go anywhere, you will just say, hey, how you doing? And then it will give you some answers, right, based on the web. But then here it is different. You just say any irrelevant prompt you give, you just say, how you doing? You'll get that there is no relevant data in the data set to answer this type of question. Okay. This is where it is grounded to open space.
We haven't had, sorry, guys.
Hey.
Sorry. You can jump on the Slack and give your presentation and get feedback.
Okay.
You did a really good job.
Yeah, so we just wanted to highlight that all of this is available in Cloudflare.
Thank you. Thank you.
It's available. It's hosted live on Cloudflare.
I think the Cloudflare people heard it.
Yeah,
Thank you.
okay. Thank you so much.
That's great. Thank you. I know this is really challenging
Yeah.
thing. A lot of you have never presented before. This is really great. I appreciate it. Next up is, you guys, what is it? Emerge conflict. Yeah, I just wanted to, I didn't really do a full introduction when I'm not the NASA New York City lead. I run a product design studio called Swarm. I also teach UX design at CUNY, and one of our students from Kingsborough, South Brooklyn. So there's also a few of my students here, like Andrea and Lamar, who've been helping out this weekend. It's really nice as a faculty member to see people come all the way to the city, schlep it up here to work. Not everybody's from Kingsborough, but we're calling you up.
Hi, everyone. My name's Tommy.
My name is Mark.
I'm doing And we are the Merge Conflicts. Our project is called AstroGuard. Our project aims to provide an interactive and engaging platform to raise awareness among the public and policymakers of potentially hazardous asteroids and potential mitigation strategies. So we have something of a three-pronged approach here, starting with our website here.
So this website is Impact Terminal. We built this website to show the NASA data behind following with potentially hazardous asteroids. It was behind this website. There's a web server which sends requests to NASA API near Earth objects, and it has its own client which receives this data, then it filters the data and give us the information about the objects which are potentially hazardous. And next object and next piece of project. Next project.
Yeah, so we also built a game for like kids and just for fun. So it picks the data from NASA and it's the asteroid data. Then you can just, I don't know, you can just fetch first fetch the data. Just refresh it a bit. Yeah, so you can fetch the data and then you start the game. Yeah, then you can shoot the asteroids. You can put a shield on the Earth. I think go ahead and shoot a few. So and then you can refresh that again. We also used an AI it's just a basic AI algorithm to create an AI mode with a few rules. The AI can actually play the game. We actually wanted to make one where like you put in the prompt and decide how you beat the asteroids just for kids and for fun. So that's it on that.
And the third part of the project was an integration with OpenSpace. So we integrated the NASA data into OpenSpace to show the orbit of potential impactors in a visually pleasing way to engage audiences. So you can see here the orbits in red are 3 different asteroids that are potentially close to the Earth's orbit. If I turn off 2 of these here, we can focus in on 2010 PK9. And if we zoom in a little bit, we can see just how close this red asteroid here is to the blue Earth orbit. And we can see here, I found a specific date, July 10th or July 11th, 2028, during which these 2 objects will be close together. And we can also play this to show how it will continue moving over time. And if we bring in the other 2, we can also see these other 2 asteroids and how they will get close to the Earth's orbit as well. So going forward, we want to integrate all 3 of these parts to enable users to choose from a list of potentially hazardous asteroids and visualize them in OpenSpace, and then interactively try various mitigation strategies to see how it will affect the asteroid's orbits using realistic orbital mechanics. This project would be used for museums, classrooms, policy meetings, to educate those various audiences on the hazards of potential asteroid impactors and the importance of preparing for these scenarios. Thank you very much. Any questions?
All right. Thank you, guys.
Thank you.
Appreciate it. There was one group who missed their slot earlier. They've been waiting patiently in the back, and then we will start deliberations.
Which group?
This is say the name.
Who's Macapa?
Say it again.
Yeah, no, Ruth Macappa. Yeah, we're Ruth Macappa, and hold on. Our project's name is Project. Oh yeah, we'll share in a second. Okay.
Hello, everyone. My name is Farhan.
My name is Rafwan.
And my name is Rasul.
And the challenge we chose to pursue is the space biology knowledge engine. And with the help of Cloudflare, we built Project Luna.
Man, I hate researching sometimes. Just like I have one single prompt, I type it in, and I gotta go to tens, thousands almost of just publications with abstracts I don't understand, right? And I know a lot of you guys hate it too. But what if I told you there might be a caveat to that? What if we don't have to spend all that time?
So the knowledge exists. So basically, NASA has been trying to. So NASA's vision has always been to reach outer space, right? However, they're trying to do something bigger. They're trying to get us to live there. So the problem is there's a lot of data that's buried, scattered, and it's hard for researchers to, find specifically what they want. It gets really time consuming, so that could affect their progress toward the goal. So this is why we built Project Luna.
So Luna comes in, as the name of our track suggests, it is a knowledge engine, and it gives researchers specific tailored questions to their research needs. And not only that, it helps guide their further research later. And so we do this by querying a large database of information context. In this case, it's the 600 plus studies of bioscience publications. And then we use that to give a more contextualized and specific response to our user.
Wait, so how does it work exactly, Farhan?
Excellent question, Rasul. So we use retrieval augmented generation, also known as RAG. And in simple terms, RAG is just another layer of the LLM that is sort of fine-tuning the response and making it stand out from giving it a reason basically why someone would not just go to ChatGPT and paste in their question. And we use Cloudflare's technologies for this, specifically their Workers AI and their vectorized database to store our vector indexes and embedding models. And all that leads researchers to get more faster and accurate results. And we display all this on our front end using React.
Oh, okay. See, I think that makes more sense. But let's actually go more into it. Let's go through the demo, right? So on our landing page, right, you're instantly met with a little search bar, and you can see at the bottom, there's a couple of commonly searched things. Just for today's example, let's say I'm a researcher who's curious about the effects of space on bone density, right? That seems relevant to wanting to live on Mars. So we're gonna go ahead, we're gonna search that. It takes some time, right? This is the RAG at work. It's thinking, it's doing a lot of processing. But once you get there, you get a very similar page to something like Google Scholar. But there's an important distinction. What we get is a direct answer. And this direct answer gives you everything scattered from the 600 publications that we had in our data set and that the RAG determined was relevant, right? So you can go ahead, read it, and it'll give you the answer. But I mean, let's be real. Researchers, you're gonna see this, you're gonna think, it can't be that easy, right? So you take it with a grain of salt. What else could we do to kind of ease that, right? You're gonna go researching anyway. And what we have here later on is a relevant research articles. So in this list, it's ranked from what is most important in the RAG algorithm to what is, at least fifth most important. And if you're curious, you can read it. So like spaceflight induced, I'm not gonna read that. That's the most important one according to RAG. If you're curious in it, you can go ahead and extract that data and you can read more about it. And this is really important because as important as it is for AI to be accurate, it's also important to know why AI made the decisions that it did. So this is pretty useful for that. It gives you a lot of direction to work with. Let's say that's not good enough. You want more. On the right side, we have some more research insights. And what it does is throughout those 600 publications, it'll give you the key topics that's mentioned in all of them. So in this specific query, we have something space radiation visible in 45 papers, bone health in 28, and so on. Again, if you're still at a lack of things to query for, you could end up typing something about space radiation. So what does the effect of space radiation have on bone density? That could be one thing. We also have a trends and data tab that we're going to fill out another time. Hopefully some graphs. And then at the very end, we also have this compare with ChatGPT button. I think this is pretty important because with the emergence of AI, a lot of researchers are going to look into how it could be useful. But in specific, I wanted to highlight the difference between the RAG model and a general LLM like ChatGPT. I think you can see the difference. There's a lot more specificity on the left with Luna. On the right, it's just general information. You can always compare the two based on the same prompt. I'll hand it back to Farhan for.
Yeah, so I just wanted to highlight, me personally, I was handling the RAG, and although I don't have that much experience with it, Cloudflare's, resources, like they have everything in one place, their vector index, their embedding models, their LLMs, and basically there was a learning curve, but cool.
Thank you guys. Thank you for hanging out. All right, so that's all the teams. If you are not a judge, you need to leave. There's going to be some deliberations, and I'm going to hand it over to Jaden to explain. Thank you for all the participants. Please continue to use the Slack. I'll put up the survey slide as well. We're still around. We're going to meet in the lobby at 4 o'clock to do the award presentation. Yes. Yeah, I think that let's clarify that now. Yeah. So I saw that one you judges have the notes. Yeah. What is your call on that? Because Jake sent around the general judging for today. Oh, yeah. So are you kind of?
We were only focused on the other one. So you all are open. Just for the overall. I say that right. I mean, you got.